All right, we're live now. Hello, everyone. Good morning, good afternoon, wherever you are. Welcome to today's meetup. My name is Dalia, and I'm from Elastic's community team. Today, we're here with James, who's going to talk to us about Limitless XDR with Elastic Security. We'll take all of the questions at the end. And yeah, enjoy, everyone. Go ahead, James.
Thank you, Dalia. Hi, everyone. Already seeing some familiar faces in the comments. Thank you all for joining. My name is James. I'm on the product marketing team at Elastic, focusing on our security solution. And today we're going to be talking about XDR, and specifically Limitless XDR. I'm going to be explaining all of this in detail, why we called it Limitless, what we're doing, what's next for us, where we're headed. So hopefully this will be of interest to everyone attending. Like Dalia said, let's leave questions to the end if that's okay. It just helps me concentrate more on the content, and then I'll just be able to get into very in-depth answers at the end. So with that being said, let's go ahead and dive right in. So I think it's important to cover a few things. First and foremost, like, who are we at Elastic? Some of you might be joining this not knowing who the heck we are in the first place. So just so everyone knows, at Elastic, we build open solutions for everyone, right? So we have a set of products which are available to everyone and anyone for free for as long as you need, mainly comprising of the Elastic Stack, or previously known as the ELK Stack as well. And we build three solutions on top of the Elastic Stack, which is Elastic Security, which we're going to be focusing on today, of course. But then we have observability and enterprise search solutions. Some of you might be familiar with the stack itself, which is made up of Elasticsearch, which is the data storage component of the stack. So you're going to be working with data if you're in security. So this is where your data sits. Think of it as sort of the database layer, so to speak. It's very different from a database, but just so people can make that differentiation. Kibana is your visual layer. So when I give the demo later, I'll be working within Kibana. Then we have Beats and Logstash, and we'll also be talking about Elastic Agent, of course, which is very a big topic for the XDR component in this. And for those of you who might not be aware, there's many ways to run an Elastic Stack. The easiest being Elastic Cloud. If you are a SaaS person, you don't want to touch anything, you don't do anything yourself, you can just head over and run it in Elastic Cloud. If you like getting your hands dirty, you can run a self-managed stack, so you can download the components, you can use Docker, you can use whatever you like. If you are a Kubernetes person, you can run the Elastic Stack on Kubernetes using our operator. And then we also have something called Elastic Cloud Enterprise. So just that's really, really, really quickly, if you're not too familiar with Elastic, these are the solutions we build on top of the Elastic Stack. But obviously, our focus today is security. For those of you who have been following our journey, I can see people like Stein in the comments already, who have been with using Elastic for a long time. And there's people like Ronnie as well in there. So hey, everyone. You'll know that we've been on a very significant journey in the security space. So all the way back before even the SIEM app was introduced. So I myself have been using the Elastic Stack for security since 2012, 2011 even. So even just before it was just Elasticsearch. And primarily back then, before we ever had any form of solution on security, it was used as your threat hunting platform, typically. So you just put all the data that your existing solution either couldn't search through, or it was maybe too expensive to do so because of a licensing restriction. You'd put it in an Elastic Stack and you'd search it. There wasn't really an interface in terms of like a security dedicated interface. There was no concept of detections. There was no concept of unified agent. None of the stuff that we'll be talking about today. So that's just the very early days of Elastic, the roll up your sleeves kind of days. There were people building full-blown solutions. I myself had built my own SIEM based on the Elastic Stack, like vanilla Elastic, as I like to say. But in June 2019, we launched the first version of the SIEM app. We called it the SIEM app back then because it was still focused on the security investigation side of things, but we gave a more curated interface. And that was really the first time we ever formally said we had a security product. Things really stepped up, though, when we joined forces with a company called Endgame back in October 2019. So for those of you who might not be too aware, Endgame were an EDR, EPP company, so basically full endpoint detection and response. Very mature product, so it's not something that had just been created. They were, They had been a company since 2008, very popular as well, especially in the US. And they joined forces with Elastic to start integrating their technology into our stack. And ever since then, we've been adding more and more features to lead us to where we are today. With the 7.14 release, we basically launched a generally available version of what we're calling our Limitless XDR platform. And we'll be talking a bit about why, but essentially we've combined the goodness of a endpoint detection and response platform and what was more traditionally a SIEM platform. And you can see the things that led us up to that day. There were certain features which had to, arrive into the stack. So things like EQL, that was a phenomenal improvement. So for those of you who don't know, EQL is our event query language, which actually allows us to correlate data, which, as we all know, if you want to be successful in security detections and security hunting, you need to be able to correlate data sources. We had things like case management, a ton of other stuff, threat intelligence in 7.13, and now here we are today with probably the most exciting release since the stack itself. Obviously, I'm biased. There have been very significant releases, but 7.14 was a huge milestone for us. And we're not, we're still just getting started. In reality, there's way more to come. So that was a bit of a background into what led us to where we are today. And you've seen this as part of, if any of you follow our release blogs and follow us and our announcements, we introduced this as Limitless XTR. And you might be saying, James, why Limitless? Like, it's a very loaded term. So we're going to be going through why Limitless today. But also, for those of you who aren't too familiar with what XTR is, I'll be going into detail about why the market has created this new acronym for us to remember. Speaking of acronyms, this is something I like to call acronym soup. So as security professionals, we're given these every single day. So like SIEM, EPP, EDR, XDR, and GAV. So there's a ton of these, right? And sometimes it's like the industry just throws another one into the bowl of soup, and we're supposed to deal with it and try and understand if we need it, if we don't need it, what it actually is it useful to me? So I'm just going to be explaining a bit about what is XDR and why we've added another acronym. When I say we, it's not Elastic. So Elastic did not come up with XDR as the acronym. This is something the industry sort of led into, and we'll be covering that. So in reality, XDR stands for extended. So it's basically call it the next step, or let's say there was obviously EDR with endpoint detection and response. We've seen that EDR platforms in a silo are not enough. So that's why people started to have EDR platforms and a SIEM solution. The convergence of those two platforms is what brings us to XDR, that's where the extended comes in. So extended detection and response, which essentially brings pretty much everything together, whether that's SIEM, EDR, SOAR. I forgot to add SOAR to my acronym soup, but that's really what this means. Let's start unifying these experiences together to make an analyst's life easier. And you might say, why do we need it? And I'm sure if you're a security analyst or you work in security operations or something like that, if you're working, for example, on your endpoint detection and response system, and you notice, let's say, hey, there's this network activity happening on this endpoint, can I check my firewall logs from in here? And typically, if you're within an EDR platform, the answer is no. I'd have to go and check my SIEM solution, or I'd have to reach out to the network team if you're not centralizing those logs. Another example is, hey, we might be seeing a user downloading files from something like S3 onto their desktop, and we're seeing the activity from the endpoint data. But to actually check something like the S3 logs or the S3 activity in AWS, or this could be GCP or whatever, that's usually in a different system. And even in terms of creating, detections based on that activity, it wasn't really possible if you have your data in different places. So this is where the need for XDR has come in, because we've seen time and time again that having those data sets in different solutions really isn't working for us. And not being able to action, which is the R in this XDR, not being able to take response actions is a pain point as well. So we need to be able to action all of this data accordingly as well. Why are we calling it Limitless? So first of all, it started with the convergence of SIEM and endpoint security, but there's more to come. Like some of you might have seen our announcement of our intent to join forces with companies like Build Us Security and CMD, leading us into something like cloud protection workloads and cloud runtime protection. So these are things that might fit into those three dots, but this could mean pretty much anything. That's where it stands for extended, but it also stands for anything detection response. So there's way, way more to come. And we believe like the Elastic Stack is the perfect place to handle this data. So why are we as Elastic calling it limitless? So there's a couple of things that we should talk about. So first one is visibility. For those who've been following our journey with Elastic Agent, which again is now generally available as of 7.14, we have several integrations within Elastic Agent. So literally, you have a policy, you say, oh, I would like to add, let's say, my Microsoft 365 events. You go, you click, you adjust your policy, it gets deployed into an agent, and you're done. But it doesn't just stop there, right? Because you still have things like Logstash, you still have things like Beats. These are not things that are going away. Logstash is still, in my opinion, the Swiss Army knife. So if there's something we don't cover with agent, you can still bring that data in. So the whole concept of not being restricted to a data source or a specific data set gives you as much visibility as you need, or as much visibility as you want. There is nothing stopping you bringing that data in to give you more visibility into your security events. So that's the first part of Limitless. The second one is data. Now, I know we're on a meetup here, so typically I try not to talk too much about commercial features. This does touch upon one of our commercial features, particularly something called Searchable Snapshots. This is very, very, very significant in the Limitless side of things, purely because you now have access to all the data you need in a very, very cheap way in terms of storage. So traditionally, within the Elastic Stack, if you had data coming into your cluster and you wanted to search it, you had to have your data sitting in what we call an index, which sits in one of your Elasticsearch nodes, which is typically solid-state drives, or the faster equivalents, NVMe or whatever, or spinning disks. It was never possible to search something like blob storage or an archive or an NFS storage system or something like that, the cheaper side of things. We weren't able to do that. But now you can. So now you can save, how many terabytes or petabytes you need in something like S3, so or GCP buckets or Azure buckets, the cheapest thing you can imagine, and still search it. But what's even better is that your analyst workflow doesn't change. This is really important, because if we told you, listen, you can search this data, but you have to take these 10 steps to be able to search it, it wouldn't be too useful. But now you have all that data available to you, and all you need to do really is change the time picker. So this is really, really significant. And I'll show you as part of my demo, I will show this, because I just want you to see, like, even though we're searching a blob archive, how quickly you can still get results. But this is where like the Limitless really takes its peak, this Limitless data side of things. Then we have Limitless Analysis. So it would be pointless to have all this data, even if it's in the frozen state, if you couldn't use it for something like detections or machine learning jobs or EQL. So you have all the possibilities imaginable to analyze, whether that's using something like our timeline or graphical event analyzer or Discover, or running a transform over the data, or building lens charts or custom dashboards, canvas reports. You could do whatever you want with that data. You can analyze it however you see fit. Heck, you can take Kibana out of the equation if you wanted to, and you can use something like Jupyter Notebooks. Why not? Python, client libraries, whatever you need. The choice is yours. There's literally limitless ways to analyze the data once it's in your cluster or in your archive. So very, very powerful stuff. And then even things like cross-cluster search, which we'll be seeing today. This now gives you the ability to even do things like cross-cluster correlation, which is really cool, and that's something I've been talking about within our Elastic ecosystem. Like, we've just given users the ability to do cross-cluster correlation, which is really, really cool. And value. So again, even if you did go for like a commercial relationship with Elastic, the way we price typically, we don't care how many gigabytes per day. We don't care about how many hosts you have or anything like that. You can deploy anything. You pay one price for everything. You can keep adding, and we don't force you to discriminate data sources. So you have all the value you can think of within your environments. So that's just really quickly explaining Limitless, because I know it's a bit of a loaded term, but it really is. Like, if you think about it based on those 4 things, there's a lot of goodness that we've packed into this release and the whole Elastic ecosystem. And that's why it's called Limitless XDR. And this is a really good slide that summarizes the possibilities today with elastic security. So the prevention, the detection, and the response, you need those multiple layers if you're ready for them, of course. Like when I say need, you have to have the maturity to be able to utilize them effectively. But you get these with the Elastic Stack now, so you don't have to think about, you don't have to decide, you don't have to choose. Let's say choose. If you deploy the Elastic Stack, you have these at your convenience, right? So if you wanted to run prevention on your endpoints, if you wanted to collect really rich kernel level data from your endpoints, if you wanted to detect based off our detection engine and the 500 plus detection rules that we give you, or you wanted to create your own, totally fine. If you wanted to take response actions, if you wanted to integrate with existing systems, this is all possible. If you wanted to run OS query, you have all of these available to you. You don't have to decide or pick and choose. It's all part of our Limitless XDR experience. With that being said, why don't I start showing you some of this stuff? And I'm going to dive in to Kibana within a 7.14 instance. And I'll just go quickly over some of these things which I've just been explaining. So let's start off with our alerts view. So there's a couple of things I want to highlight, particularly which talk into the whole XDR experience. Also some of the things that tie into the limitless part of that XDR experience. And the first one is, let's talk a bit about the limitless analysis side of things. So I want to start off with that whole cross-cluster correlation aspect. So this is something we introduced in 7.14 with EQL, with our event query language, the ability to run EQL over using cross-cluster search. This wasn't possible before. And the use case I have here is, it's one of the things I mentioned in the slide earlier. So let's say I have data on an endpoint. Actually, let me go back a bit. Let's take it a step back. So imagine I'm investigating a host. I can see here I have an alert for potentially malicious host name has been queried. I'm going to use our event analyzer as my first analysis step, one of my many limitless options. And I can see that as part of my analyzed event, where I can see run DLL32 has made 114 network requests as an example. And I can see it's making requests to this CDN and verify.net. This is a DNS request. This is all coming out of Elastic Endpoint, by the way, which is an Elastic Agent integration. And I can see that on this endpoint, I have network activity, which is basically saying CDN verify.net is resolving to this particular IP address. So imagine I'm an analyst. I've seen this for my endpoint, but now I want to check if I have any network traffic on my firewalls to that particular IP address. If you're living in just the EDR world, this would be the point where you either switch systems, or you'd have to reach out to the other team, or reach out to the other product, or whatever. But within Elastic, we have the capability to do both. So imagine I wanted to run a correlated search for this IP address. So I want to see, hey, let me see if within a particular time frame I had network requests from this particular process to this IP address, and then followed by requests on our network firewalls to this IP address. But let's take it a step further. Imagine my network data was actually in another cluster. We can do that with Elastic. So that's what I have here. I actually have two clusters. I'll just show you. If we go to the overview page before I run the correlation search, we're using cross-cluster search here. So for those of you who aren't familiar, cross-cluster search allows you to query a remote cluster, but it's totally transparent. It's as if you're sitting in one place. And this is denoted by this notation here. So you can see this, wherever you see an index pattern with a bit of text, colon, and the index pattern, that means it's a remote cluster. So the vast majority of this data is actually living in a remote cluster. And one of the data sets I have are GCP. So I have data from GCP firewalls inside this remote cluster. So what I want to do is I want to correlate the endpoint data, which is sitting in this cluster, with the GCP firewall data, which is in the other cluster. And thanks to EQL and cross-cluster search, we can do that. And I have a safe timeline here. So timeline is one of the ways you can use EQL. And I have that saved here just so you can see what I'm about to do. And basically, this is going to correlate across those two clusters. And what we're searching for is pretty much what I described earlier. So we're going to look for network events, specifically endpoint network events, where the process name is run DLL32 and the destination IP address is that IP we saw earlier. But then I want to look at my network events specifically from my GCP firewall, but I want to correlate based on the destination IP. So where EQL allows you to do this thanks to this by statement, this by destination IP. And we have results here. But I want to show you that the second event in the sequence is actually a different cluster. So if I just view the details of this event, you can see the index is a remote index, which is, again, that different pattern. And the first one is actually a local index. So we just did cross-cluster correlation, which is really cool. And I don't know if you noticed, but this didn't take any time at all. There's several millions of events here, and it was still really, really quick. So really, really nice. This is one of those limitless things. And also where you can see the convergence of data sources coming together, even if they're in remote clusters. You might be asking me, James, why would I have a different cluster for my GCP firewall logs? Well, there's certain reasons. One is if you live in multi-cloud environments, which is very, very common, you avoid having to pay things like data transfer costs between cloud providers. So you can leave your GCP firewall logs in a GCP Elastic Cloud cluster, for example, and then you have everything else living in AWS. You just avoided having to transfer data and paying those very expensive data transfer costs. That's one reason. But even in terms of scale, sometimes it's easier to scale systems by having data in different clusters. So if any of you had joined my sizing for security session, I specify this in depth. Like I talk about cross-cluster search quite a lot, and scale is one of those reasons as well. So those are some of the reasons why. But now you can actually correlate across them again. So we just did cross-cluster correlation. I think that's really cool, and it's going to open up a whole new world of opportunities for both detection engineering, but also threat hunting as well. Excellent. So that was one thing. Let's talk about something else. So imagine we go back to our alerts view. And now that I've noticed bad activity on that particular host, for example, and I had the event analyzer, how do I stop that host sending those network requests? So this is where the R comes in, the response actions. So in 7.14, we started adding response actions, and the first one was host isolation. So you now have the ability to take a host off the network. What this actually does is it kills the network connectivity at the kernel level. So we don't rely on any third-party software. We don't use like Windows Firewall or anything like that. It's done at the kernel level because we don't trust any other software that's running. That's typically the best practice. And it's available right here. So if I go to take action, I have an isolate host option. This will take my host off the network. I can leave a comment. Let's just say this is for the meetup. Confirm. And that's going to isolate my host. So right within the analyst view, I didn't have to leave any other screen. I didn't have to go to another system. Even though this is running from a detection engine alert, I was able to isolate that host. So really powerful stuff. This is just the beginning. Of course, we will be adding more response actions, but that's obviously part of the R of XDR. And you can see now that host is isolated. What's nice about this, because some of the other things we're going to talk about require it, even though it's isolated, you can still interact with it, which is pretty cool. So another part of the XDR ecosystem is the ability to query hosts, right? So we introduced an integration for OS Query. So for those of you who aren't too familiar, OS Query is an extremely powerful open source tool developed by Facebook, actually, and I think it was first introduced in 2014. Basically, OS Query turns your host into a queryable relational database, which is really nice. So you can do things like select star from logged in users or select star from ARP cache, things like that. Really, really powerful. The problem with traditional OS Query deployments is, it's very hard to manage at scale because it doesn't really come with like a management interface. You can use things like FleetDM, which is a very powerful open tool as well. But what we've done is we've built the OS Query management right within Elastic Agent. So now, even though my host is isolated, I can still interact with that host. So interactivity from a typical like detection and response platform is now available within the same workflow. So if we just head into OS Query here, so this OS Query will show up as long as you have the OS Query integration enabled. You can run really powerful queries. So I just select my agent. I only have one agent in this case, but even if you had multiple agents, you'd be able to do this. You can either use a saved query, which is really nice, or you can simply start typing and we'll do even things like autocomplete. So I can do stuff like select star from logged in users, for example. Submit, and then I'll instantly get my results if I have any. Plus, we'll give you the ability, if you wanted to use these results in something like Discover or Lens. So you see here, these will load up in a second. I can, hopefully they'll load up in a second. Obviously in demos, sometimes things go wrong. But essentially I can interact with them as if it was just another data set, which is really good as well. So OS query, very powerful, very useful to be able to do some ad hoc investigations. Let me see if I can load up a previous query. Let's just see this one here. Actually, what I want to do is view the results. So this was an example of me querying the host table, and I got results back. So these results are saved as another index. So then if you wanted to use these with EQL, for example, or you wanted to create your own dashboards or discover searches, whatever you want, this is also possible. So what we've done is we've live queried an isolated host, or almost, because my query did not work successfully here. But you get the idea. We've just been able to do that as part of our investigative workflow, which is really, really powerful. So there are some stuff you can run here, like, let's see if I can load up some of these previous queries. You can even do things like select Chrome extensions. Like there's a lot of, I think there's like 278 tables that OS Query gives you across all operating systems, by the way. So this works for Linux, Windows, and Mac OS as well. So really powerful stuff. So that's another part of the Limitless XTR solution. But obviously, some of the more important things are, so far we've been doing reactive work. What about proactively stopping bad activity? So this comes into the prevention aspect of the in the XDR world. So if we go back to the alerts view here, you notice that some of my alerts in my table were actually for malware prevention. I'll just get rid of this. So obviously, you also have malware detection and prevention on the endpoint. So even before malware has time to run, it can automatically kill it or stop a running process or quarantine a malware file if we detect it. So you also have this available to you as well. This is obviously one of the free features as well. So malware detection and prevention is 100% free across all operating systems. So on 7.14, we also added this for Linux environments. Which is really, really nice. So now you don't have to think about it again. If you're running a Linux host and you wanted to have malware detection and prevention, you now have it as well. With the ability, of course, to take those response actions too. So really powerful stuff as well. So again, just to recap that, even before you used the detection rules happening in Elastic Security, which is your other layer of defense, you've prevented it from running. In this case, I had it running in detection only mode, but you can have this running in prevention, which is great. Just to show you as well, so if we look at what I'll do is I'll turn on the event renderers here. So for those of you who aren't aware, we have event rendered views, which basically get the data and play them out like a story instead of you having to expand the events to see the detail. And you can see here, for example, for this malware detection alert, it's saying that James in this domain on this host was detected creating a malicious file. So in this case, we detected that file with those arguments. So you could have prevented this from even running, which is obviously a big part of XDR, the malware detection and prevention. We have the same for ransomware, by the way, and we have multiple layers of ransomware detection as well, which is very, very nice. So that's also another big part of it. But what else? There is more. So I'm going to touch up on that searchable snapshot feature. So the frozen data. Again, I know this is Meetup. I typically don't talk too much about commercial features, but this is so good, I do have to show it. So this cluster in particular, just want to show you this a bit. It has access to a 300 terabyte snapshot of packet data. So it's living in a Google Cloud bucket, and I'm able to query it thanks to searchable snapshots. What I want to do is I want to show you those list of indices and how they have 0 bytes on disk. So wherever you see this index pattern frozen dash packet beat, these are living in that archive. But you can see they're still green, which means I am able to query this data, but storage size is 0 bytes. And there's hundreds of millions of documents here, literally hundreds of millions. Again, it's 300 terabytes worth. So what I'm able to do is I'm able to query this. So let's say we go back to timeline. And I just want to show you the experience to be able to query that. So I have here again, I have a pre-saved timeline. And I want to search for this IOC, this host name for cdnverify.net, which is what we saw in one of the previous alerts, which was what that endpoint was reaching out to, right? So that IP address was to that cdnverify.net. So what I want to do is I want to say, hey, let's go back 2 years in this case. So you can see September 2nd, 2019, and see if I had any other hits for cdnverify.net. This is actually querying that archive. So I'll show you later how the indices in this case are searching for frozen dash star. But as an analyst, all I had to do in reality was change that time picker. Now, obviously, because this is an archive, this is going to take longer than your traditional search. So that's obviously a trade-off. If you're going to search something which is not disk, we do expect a search performance, a hit on search performance. But that's expected. If we're going to be searching 300 terabytes, it's okay if it's sitting in really cheap storage. We still get the results back in minutes. So I'm just going to let this run. I think it takes about 5 minutes to get results back. We do cache certain parts of the data, by the way. So if you run the search before, and then you run it again, we do cache certain elements. So if the first time it takes a few minutes, the second time might take a few seconds because we cache certain elements of that data. So I'm just going to let this run, but I just wanted to show you the experience in something like Timeline, how easy it is to run this. Like literally all I changed was the time picker. In my case, you saw I named the data as frozen-star. That was just me naming it that way for the demo purpose. In reality, if you're using something like index lifecycle management, you probably don't even need this step, because by default, if you wanted to, it will search those frozen snapshots as well. So just to show you what that looks like, you might be asking me, but how do I set this up? Let me open this in a different tab here. And I'll just show you what that looks like real quick. So it's just part of the index lifecycle policy. So let's create a new one, just show you. So you have your hot, your warm, your cold, and your frozen. So you can go straight from hot to frozen if you wanted to. But you can see searchable snapshot. So you just pick your repository, whatever that may be. You can have repositories in any supported storage we have. So again, there's a whole list of what you typically take snapshots into, so it's not restricted to one type of storage. But that's it. Once your snapshot goes from hot to frozen, you can search it and it's in your archive, which is really, really cool. So you can say, listen, I want to move it to frozen after 90 days, or even, heck, 7 days. So from my hot storage, it goes straight to frozen after 7 days. You assign it to an index, and that's literally all it takes. And you'll be able to search that data. So really, really simple, really easy to use. Let's see if we got results back. We got results back. So this search to run over 300 terabytes of an archive, not of disk, of an archive, took, I'm just going to hit the inspect button here. It took 162,000 milliseconds. If someone wants to do the math, I think that relates to 3 minutes, something like that, which is impeccable for that volume of data. And you can see the first hit we got was from December 4, 2020. So just to recap, we searched for cdnverify.net on a 300 terabyte archive stored in a Google Cloud bucket, not changing the analyst experience, not changing the analyst workflow, simply changing the time picker, and our storage is in a really, really cheap place. So I had to show this because it's so phenomenal, and it opens up a whole new world of possibilities for any of us in the security world, either doing detections or analysis or data. Just too good to not talk about it. So I just wanted to, this is a big part of our Limitless story, so I just wanted to highlight that. Perfect. Okay, so we covered that side of things as well. Last thing I'll talk about is, I might have probably should have started with this first, but it's okay. Obviously, we have the Limitless Integration side. So for those of you who haven't followed our Elastic Agent story, which is generally available as of 7.14, you can now simply pick integrations from our list of available integrations and start collecting data from them immediately. So there's several integrations here. You'll see endpoint security is one of them, which is right here. You'll see things like other security ones, like Okta, Office 365, Nginx, or Query Manager is right there. So there's a lot. So what this means now is, so let's say I start off one day and I'm like, you know what, from today onwards, I would like to run malware detection and prevention on all my Linux hosts. All I do is I change my existing policy. So as long as they're, of course, running Elastic Agent initially. So if I go to Fleet here, I can see right now I have one agent. These are the integrations I have for this agent. So I have OS Query Manager, I have Elastic, I have endpoint security, and I'm also running Windows because I have things like PowerShell logs that I want to collect. But literally, I just tick a button now, or I add a new integration, or I make a small change, and I'm now collecting or detecting or preventing across my entire fleet. That's why it's called Fleet. So obviously, this is really impactful for anyone who has hundreds of thousands of hosts. Traditionally, this was a bit of a pain in the Elastic world. If you wanted to manage your beats, you had to create your own scripts or use something like Ansible or whatever. Elastic Agent really solves that cumbersome problem. And obviously, that, again, plays into the limitless integration side because there's just so many. If you wanted to combine this with something like Logstash, that's totally fine. But obviously, this makes your lives very, very easy. And you can see here again how easy it is to go from something like prevention to detection. If I wanted, from today, I don't want my DNS events anymore, I just tick the button. And again, these are all like kernel level telemetry. So it's not relying on local logs or anything like that. This is all coming straight from the operating system. So we had to talk about that. And again, for example, in my case, if we go back to integrations, in my other cluster, where, because we did the cross-cluster search, if you remember, I had things like Google Cloud Firewall logs. So you can see here we have GCP. So even like cloud workloads. So everything is in there. Not to forget to mention, by the way. So we've been talking about Elastic Agent a lot, of course. If you are already running an existing endpoint solution, that's also totally fine. Like we do not discriminate. If you wanted to bring data into Elastic Security from another popular vendor, such as CrowdStrike or Microsoft or SentinelOne, whatever, we have a lot of integrations that can help you there. So for example, you'll see one for CrowdStrike, you'll see for others as well. So even if you have existing solutions, you can still bring it in. Obviously, there's a lot of features like the response actions on the endpoint. For now, it's still for our integration, but eventually we will open up response actions to third party as well. So just to make you aware that we're not going to just restrict everything to just the Elastic ecosystem. The plan is to be as broad as we can be. Perfect. All right. So I think from a demo side, that's really all I wanted to talk about. Actually, one more thing I'll show. Because all of this, we started off from an alert workflow. This is also really important to highlight. So some of you might not be aware that we ship with, again, 500 plus detection rules, which are totally all developed in the open, by the way. So some of the people on this stream are heavy contributors. So thank you to anyone who's contributed to our detections, because you just make everyone's life easier, to all our community. So you have access to, from day one, as soon as you start using Elastic Security, literally here, 568 detection rules, which cover a very broad ecosystem of security technologies as well. So you see things like Azure rules, GCP, AWS, Microsoft 365, Google Workspace, Linux, macOS, you name it. So there's, again, this is obviously a very core feature. And they're all here. So if we go to github.com/elastic/ just get detection rules. And they're all developed in the open. So you can go today if you wanted to, just check them out, or contribute or submit a pull request, do whatever you want, but they're all developed in the open, which is a big thing for us, because we don't believe in security to obscurity. Everything is out in the open for everyone to see. And not to mention as well, like if you wanted to get just to view these rules, just to get an idea of how they're built or what we're looking for, but you're not necessarily using Elastic Security yet, that's totally fine. Even if you want to get an idea of how to build detection logic, potentially in some other platform, that's okay. Like, we don't mind. So if you wanted to see what we're doing to detect a specific threat, you can go and see what we're doing. So this is an EQL query, for example. You can sort of build off of that. If it makes your life easier, please go ahead and use whatever you need. And you can see as well, they're all mapped to MITRE ATT&CK, by the way. So this is something I haven't talked about too much yet, but all our detection rules are mapped to the MITRE ATT&CK framework. And I think all of you know what that is by now. But for those of you who don't, MITRE have done a phenomenal job of mapping attacker techniques according to their specific behavior. There's sub-techniques listed as well, and it's all listed. It's called the MITRE ATT&CK matrix. And they have multiple matrices depending on what you're working in, whether that's Windows environments, which is the most vast, but even cloud workloads, Docker, they have it all, which is fantastic, because now it gives us a much easier way to get started when looking for certain threats, or even protecting against threats. So that's it from the demo side. I'm going to start taking questions. I know there's a few already. So there was a question about the malware detection. So I'll talk a bit about that. So it's a combination of things, actually. So on Windows, we use something called malware score primarily. So malware score is actually a supervised model, so based off of about hundreds of millions of malware samples. So primarily, whenever a file is written to disk or executed, we extract features from that file, compare it to our model, and depending on how close it comes to the model, we determine if it's malware or not. This is also found on VirusTotal, by the way. So if you upload a file to VirusTotal, it's run through this same malware score. Same thing happens for macOS, but for Linux, we took a different approach because there aren't enough samples to build a valuable, I should say, an efficient model yet for Linux. So what we do is we're using YARA rules under the hood. So that is going to be signature based. However, what we've done is it's actually really cool. We had a talk at Black Hat about this. Black Hat happened last month, about how we're collecting these and putting together these YARA signatures. Really interesting stuff. So that's how we're doing it on Linux. And we're probably going to do some of that on Windows as well, just to get the combination of both signature and signatureless detection for malware on Windows. So that's what we're doing for malware. For ransomware, there's obviously that is the first step, because a lot of ransomware binaries actually get picked up by malware score initially, but we do go further. So we also have canary detections for ransomware. We also have behavioral detections for ransomware. We also look for things like we also protect against like master boot record attacks on ransomware, because that's something we've seen happen in the wild as well. So there's a lot we do for ransomware too. So that's what we're doing from a malware and ransomware perspective. Thank you for asking that question. All right. Are there any others? I don't see any other questions in the chat. So, but if you have any questions, now is a great time to ask, and I'll be happy to attempt to answer them. Hopefully, I'll be able to answer them. Set frozen data is very, very, very cool. I'm glad you said that, because every person I've shown it to, or every user that's seen it, has said the same thing. The first time I saw it as an Elastic employee, I was blown away. Like I didn't believe it. I thought they were showing us a recording and it was sped up or something. But it's really, really phenomenal. What the Elasticsearch team have, well, all the teams involved, what they've pulled off is incredible. So it's definitely going to be felt by anyone using Elastic. Stein is asking, can you use actions to automate host isolation? Not yet, Stein. There aren't API calls for actions yet. Probably will happen eventually, but nothing just yet. You're very welcome, Ronnie. Yogesh is asking, can you refer material on indexing and mapping documents? We can send out links. So there's a couple of things you might want to, if you're starting from like that level of Elasticsearch, if you want to understand like indexing and mapping, there's some other previous meetups and webinars that you can watch. That's probably going to be your like fast track to understand how that works. Obviously, our documentation is helpful as well. So those are two things I'd recommend. We can send out a few links probably after this. Jason has asked, what is the best training for the features? Great question, Jason. So we do have security training out there. Since this is fairly a new release, so it only happened a few weeks ago, we haven't caught up yet from a training perspective. It is coming very soon. So for now, hang tight. As soon as there's updated training available, I'm sure you'll be notified. In the meantime, we are hosting a ton of webinars and videos. So this is one of them. There's going to be more that get into like starting from scratch as well. We have our Elasticon Global coming up in October. There's going to be a ton of sessions then that get into very specific details for certain features as well. So I do recommend you join any sessions that you can. It's all virtual. You can just join as many sessions as you want or like. Lawrence is asking, are the frozen snapshots kept at 0 bytes even with rates of change? I'm not too sure what you mean by this, Lawrence. So that 0 bytes is the storage on the spinning disk or like SSD. So it means it's not taking up any of your storage from your cluster. On the snapshot itself, of course, that is taking storage from like whatever you're using, S3 or GCP. So I'm not sure if I understood the question correctly, but that 0 byte is referring to the actual disks on the cluster. And thank you for sharing the link, Dalia. Are there any further questions? Can be about anything. Feel free to ask me anything. Well, Elastic related. Or about cats and coffee, because I can answer those questions as well. All right. So I don't see many more questions coming in. So we'll probably give you 15 minutes back or 14 minutes now. So thank you all for joining. This will be on our YouTube channel even after we finish streaming. So feel free to watch it again. Oh, there's no question there. So SOAR. SOAR is definitely something we're thinking about. It's not available just yet. You can integrate with existing SOAR platforms. So for example, you've seen our integration with Swimlane, but it's not something we're actively working on just yet. It's just something we're thinking about, but you'll see that in future. Jason is asking utilization testing results of the EP agent. So Jason, I would say the best place to go for these is our AV comparatives reports. So we are certified on AV comparatives and OpSWAT as well. AV comparatives do extremely good testing on things like utilization. So you should probably check those out if you can. No Name is asking about my sizing for security. Yes, it is on our YouTube channel, our community YouTube channel. So feel free to find the link there. So you can find it right within the channel. Stein is asking, any tips for using honeypots with the stack? So there's many tips. There's many things you can do with honeypots. So depending on what you're trying to do with the honeypot, if you're just using it to collect data passively, there are many types of honeypots out there, like even very common ones like Teapot and stuff like that, which integrate really well. And they write everything to JSON. There's so many types of honeypots these days. Some of them are written specifically to send data to Elasticsearch. What I would say, of course, is any honeypot you use, try and get ones that write to ECS. So you can either utilize the out-of-the-box views for the analysis, and also potentially use some of the detections, because we do have network-based detections as well. So if you have a honeypot that's looking at RDP connections, SSH, stuff like that, we have detection rules to look at that if that's something you're interested in. So if you find one that writes to ECS, it would be great. If not, you need to build an ECS pipeline for it. Also, if you are a Platinum user, which Stein, I know you are, obviously honeypots and machine learning go really, really well together, because you can find some really interesting stuff. So definitely try that out from a honeypot perspective. Lorenzo is asking, do you test your supervised models against adversarial learning attacks? So the supervised models we have, Lorenzo, are specifically for malware files. So looking at primarily Windows PE files, so portable executables. Then we also have some supervised models like from on the stack side. So we actually ship a supervised model for domain generation algorithm attacks, and also problem child, so living off the land processes as well. There's very detailed blog posts about those, and they're tested against real world data. So a lot of work goes into those. Those are actually available completely free and open as well. So you should check those out if you can. So there's those supervised models, but the models I was referring to in this talk were about the actual malware executables. Connor is asking, did you create a dedicated frozen data instance to help with resource power? This have different behaviors when just freezing indices? Yes, this is different. Good question. So there's it's kind of get a bit confusing, because there's frozen indices and then there's searchable snapshots. Searchable Snapshots is actually new. It came out earlier this year in terms of being generally available. Frozen indices have been around for a while. To be able to search data on the frozen tier for searchable snapshots, because there's also searchable snapshots in the cold tier, you need to have frozen nodes. So your nodes have to be labeled accordingly to be able to do that. So yes, you would want dedicated frozen nodes. In my case, I had dedicated frozen nodes as well. If you live in Elastic Cloud, you simply specify that you would like frozen nodes. The reason you specify frozen nodes is obviously they're going to have a very, very, very different memory to storage ratio and things like that. So all of this is actually detailed. We have quite a few blog posts and how-tos as well. And there's one specifically for searchable snapshots about how the team was able to query like a petabyte of data in 10 minutes, something like that, which is pretty phenomenal. So if you're interested in finding out more and sort of what the specifications they used and the hardware they used, I definitely recommend you check out that blog post as well. And just to reiterate on that, so the freezing indices that you mentioned in your last sentence, that was a feature that we had introduced. Can't remember which version, but it was a while ago now, where we introduced the concept of being able to search an index without it having to use up any of your Java heap. So any of it, they didn't live in the JVM. Which was sort of like a precursor to what we did with searchable snapshots. Totally different technology, but that's just the difference here. So frozen in the, let's say, non-searchable snapshot sense means you can search through indices which don't live in the JVM. Searchable snapshots in the frozen tier means you can search an archive. So totally snapshot it off the cluster. We've basically decoupled compute and storage completely. Thank you for the reminder, Stein. So yes, if any of you have any other follow-up questions or want to join a super cool active community, which a lot of the people in the chat are on, please join us on our community Slack, totally open workspace, which is, so you can just go to ela.st/Slack and you can join our community. I'm on the security channels all the time. There's a bunch of other Elastic people, but there's also a lot of people on this chat as well. So Stein, Annabelle on there. There's Ronnie who's on there as well. There's Parth who's on here as well. So there's a lot of people in this who are very active in our community. I just want to say thank you to everyone who's on our community Slack, because it's great to see how you all collaborate between each other. Like, it's really phenomenal that we're all helping each other in this very difficult security fight. For any of you who are in security operations or security analysts or have been on the front line, I know it's been a really, really tough couple of months. Can't seem to catch a break. So joining these communities really helps, because you can just ask questions, you can get immediate feedback, immediate advice, especially if you're newer to Elastic. Mohammed is asking, as I recognize, there's more than 4 agents deployed at the endpoint, which may be rejected by a lot of customers. Is there a way to minimize these agents to 1 with enabling modules? So Mohammed, if I understand you correctly, I think you're saying that when you deploy Elastic Agent, it actually spawns up for a couple of different binaries, which are primarily under the hood, running file beat, metric beat. Elastic Endpoint is its own binary, and then there's also OS Query Beat as well. Yes, those are 4 different ones. We are working on a better architecture for that. I don't really have a time frame of when that will be. But yes, right now they are spawned as different child processes under Elastic Agent. But we are working on simplifying that and making it better. All right. Thank you for all the questions that just came in. We have about 6 minutes left. Dalia, I just see you made yourself present.
Thank you very much, James. It was really, really awesome to see how else you interact with the crowd. Let's see if we have any more questions before we wrap it up.
Thank you, Casper. We appreciate that feedback. We will keep delivering killer features, I promise. So there's a lot more to come. Not too much I can say for now, but yeah, it's very, very bright future for Elastic Security. So thank you for that feedback. Yeah, thank you for joining the session.
Yeah. Thank you very much, everyone. It was a pleasure having you here today, and the recording can be found on the same link as you're watching it right now. And yeah, hope to see you at our next meetups. Thank you very much, James.
Thank you, everyone.
Bye, everyone.
Great day, evening.
Bye.